Yeah, hello? Hello, are you there? Hello? How many of y'all sick of doing these Regents exams? Huh? Are you sick of them? I don't care. You gotta work in life to be successful. If you're cheating, this is not the place for you. You're just gonna make me mad. If you've done your work and you're just checking your answers, you're my freaking hero and I love you to death. I don't really love you, but you're a good kid and I really hope you do well. If you get 100 on your Regents, please email me. I'd love to get my wall of fame up going. Been teaching 20 years. Still have yet to get a kid get 100 on a Regents exam. Lots of 99s, 98s, 97s, lots and lots and lots of those. It takes kind of a freaky mind to get 100 on a Regents exam. Freaky, freaking diggy. So if you get it, you're a freaking hero. You guys ready to roll? You guys ready to rock and roll? Rock and roll. We are on the last part of January 2014. We're going to be doing those extended response questions. Good luck, kids. Let's go. I have no idea what page I'm on. Not that one. There we go. Oh my goodness. That's 28. Oh, that's 30. Wrong page. Somehow we gotta be. Oh, I don't know what. Okay. I am missing a page. Apparently I'm missing a page. That is odd. Let me just see if I got the page here somewhere. No, 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 no. There it is. Page 10. Page 10. Page 9. Nope. Ah, hey, somehow they came out of order. So let's just get going. There's 28. Sorry about that. Didn't realize that was going to be a mistake. Who'd have thought that? Okay, we're going to show that secant times sine times cotangent is really 1. Guys, you have to have this stuff memorized. Secant is 1 over cosine theta times sine is just sine. Sine theta over 1. And cotangent is cosine theta over sine theta. Alrighty, and we want to show that this is equal to 1. Can't touch the 1. Can't touch this. Can't touch this. So this cosine cancels with this cosine. This sine cancels with this sine. I get 1 equals 1. Catching! Remember, those 2-point questions are not supposed to take a long time. Find the nearest tenth of a square foot the area of a rhombus that has a side of 6. So if I have a rhombus, that's my best attempt at a rhombus, all sides are the same, and we have a 50-degree angle in the middle. Now, if you remember correctly, we're going to use this formula. Why can I not grab this? We're going to use this formula up on top that says 1/2 AB sine C. That's area. Now, that's area of a triangle. Remember, that's not what I have here. What I actually have here is 2 identical triangles. So K equals 1/2 AB times sine of C works beautifully for a triangle. That'll give you this triangle. Then you multiply by 2 to get that triangle. Or we just get rid of the half. Because this is the area formula then of a parallelogram. So K equals 6 times the sine of 50 degrees. So I come over here to my calculator and I do 6 times sine of 50 degrees. Wow, what a mess on my calculator. 27.577. So K, which is the area, is 27.577 rounded to the tenth of a square foot. My area is equal to 27.6. Done. Let's go to page. Oh. Well, why was page 10? Oh, I don't know. Maybe it's the new page 10. I don't know what's going on. Doesn't matter. Page width. Here we go. The following is a list of individuals. Let me make sure I'm on the right page. Basketball. Find the interquartile range for this data. So what we need to do is we need to come over to our calculator and type this stuff in. So we're going to go to the home screen. If you're on a TI-84, you got to go type and put these in list 1. I'm going to put these in a list. See, I got somebody else's crap in here. Got to get rid of it. I don't want anybody else's crap in my calculator. Boom. There it is. So I'm going to type these things in. Well, first of all, I'm going to give this thing a list name. I'm going to call it X. And then I'm going to go 2, enter, 2, enter, 3, enter, 4, enter, 6, enter, 7, 9, not 1, 10, 10, 11, 12, and 14. By the way, one of the biggest problems made is not putting the right numbers in, or not putting in all the numbers, or typing in the wrong numbers. Check it yourself twice. Do this problem twice. It's not that hard to do. So what we're going to do is we're going to go into Menu, Statistics, Stat Calculations. Not Stat Calculations. Well, I hit the wrong thing. Menu, Statistics, Stat Calculations. And what we want to do is one variable statistics. We have one list of numbers. It's in, we called it X, and we want to click OK. And what we'll get is what we're looking for is our 5-number summary. We're looking for that 5-number summary. And there it is right there. The min is 2. The min is 2. And you want to write this stuff out. Quartile 1 is 3.5. The median, or quartile 2, is 8. Quartile 3 was 10.5. And the max was 14. If they asked for the range would be using the 14 and the 2, and that would be 12. They asked for the interquartile range, and that is the difference between these two. And the answer is 7. You take 10.5 and you subtract off 3.5, and the answer is 7. That is the interquartile range. That's it. Done. Determine algebraically the x-coordinate of all the points of these graphs. So you have x times y equals 10. And I also know that y is equal to x plus 3. So what I will do is I will plug that in for y. So I'll do x times x plus 3 equals 10. And now I got a simple quadratic to solve. X squared plus 3x. And then I'm going to bring the 10 over, set it equal to 0. I will factor this. Factoring is very easy here. X plus 5, x minus 2. They multiply to 5 and add up to negative 2. And so my two answers are x equals negative 5 and x equals 2. Moving on. By the way, I always want to tell you about ways to check your answers. You go into graph mode. I probably have somebody else's crap in there, so let's get rid of it and go back into graph mode so we don't have anybody else's crap in there. And I want to graph in, now that first one was xy equals 10. Well, if I solve for y, that would be 10 divided by x. Choose enter. And then my other graph was y equals x plus 3. So I'll just hit tab and then do x plus 3, enter. And you see they're going to hit at 2 points. And it looks like one x value here is negative 5, and the other one here is positive 2. And see where they hit the x values? They wanted the y values. The other thing I can do is to really make sure I go menu, trace. I can try graph trace. Sometimes that works. I don't even know where is this thing? No, I don't know why it started way up there. It passed right over that. So it doesn't pass. So maybe what I want to do is menu, analyze graph, intersection, and go left of it, go right of it, and say, oh look, there's an intersection of 2, 5. One of my x values is 2. That's just another quick way to check your answer. Moving on, page 12. All right, ding, 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 ding. I see a absolute value. That means I'm going to solve 2 problems. Not 1, but 2. the original 4x plus 5 less than 13, and the negation of everything on the right side, including whatever inequality sign is there. So you don't touch the left side. Can't touch that left side. Don't touch the left side. Can't touch that. But we're going to change it to greater than negative 13. So you have two problems solved, the original and the negation of everything on the right side. So if I solve this, the other thing that I'm thinking of, kids, while I'm solving this, is I've got that negative 4x. And I have to remember that when I divide by a negative, you have to remember to flip the bloody sign. It's not really bloody. I'm right. So it's x greater than negative 2. Notice I flipped the inequality sign. Subtract 5. I get negative 4x greater than negative 18. Divide by negative 4. Divide by negative 4, and I get x less than 4.5. Oh, I must have done something wrong, Mr. Krause. I got a decimal. Just kidding. You can have decimals. But what you ought to do is take a look to see what this looks like on the graph. Here's negative 2. Open circle going that way. Here's 4.5. Open circle going this way, so we connect the dots. So my answer is, you can give the answer. It doesn't say how you have to give your answer, so you could give it an interval notation. Interval notation will be negative 2, comma 4.5. Or you can give it in standard notation, negative 2 less than x less than 4.5. Either one of these would be acceptable. Don't give both, because if you screw up on one, you still got to take off credit. Don't be like the smart guy. Oh, I got to give both. All right, so they want this in simplest a plus bi form. It's a great way to ask this question. Let's talk about our I circle. I to the 1 is just I. I squared is negative 1. I cubed is just the opposite of that, which is negative I. And I to the 4th is really just equal to 1. So anytime you have a multiple of 4 on I, it's just 1. So let's see what we got here. We've got 4xi. I can't do anything with just an I, so that's just 4xi. Plus 5y. Now I to the 8th is a multiple of 4, so that's just a 1. Plus 6x I cubed is negative I. And then finally we've got this plus 2y I to the 4th. Well, I to the 4th is just 1. So what I end up with is 4xi plus 5y minus 6xi plus 2y. All right. And they want it in a plus bi form, so whatever is not imaginary comes first. That's the y's. That's 7y minus 2xi. And that's in a plus bi form. Done. So, what do we got here? In the arithmetic sequence, arithmetic means we're going to add up. We got a to the 4th equals 19, a to the 7th equals 31. We want to find a to the nth. We want to find that formula. So how are we going to do that? 1, 2, 3, 4, 5, 6, 7. This is 19. And this is 31. So the difference between these two is 12. Agreed? If we take those difference. So what I got to do is figure out what I got to add to get 12. Or I'm going to add it once, add it twice, add it 3 times a lady. So I'm going to guess if I add 4, 12 divided by 3, that gives me 23. Add 4, that gives me 27. Add 4, that gives me 31. So my common difference is 4. That's going to become important. I got to figure out what the first one is. And I'm just going to keep subtracting 4. It's probably the easiest way. 15 11, 7. There's my first number. So my formula will be a sub n equals 7 plus 4 times n minus 1. Rock on, kids. Hope you got it. You should have learned sequences at some point in your career. That's it. That was an easy one. All right, what do we got here? Arc length subtended by that degree. Oh my God, we've got a subtended article. Okay, guys, look. I use the formula S equals theta r. S is arc length. Theta is the angle in radians. That's the hard part always about these. The kids just completely I didn't say it. And this is clearly just the radius. Well, we're in great shape. We got the angle, we got the radius, we should figure out what x is. So in this case, x, which is I'm plugging in x because that's what they're calling the arc length, is equal to, got to convert 83 degrees 50 minutes to radians. To convert from degrees to radians, 50 minutes, you multiply by pi over 180. So we're going to come to our calculator, and we're going to say, okay, get rid of all the garbage. We're going to say, let's go in the degrees, minutes, seconds. I'll click on this. So 83 degrees. I forgot what it was. Was it 50 minutes? 50 minutes times control division pi over, that was weird, pi over 180. Enter. So that's my radians. Those are my radians. Now I'm not going to round that. Don't round it yet. So I've got 1.463. Don't remember what the rest of it is. 167. 68. That should be enough. Times the radius of 12. So really what I'm just going to do is take this and multiply it by 12. And 17.558. So x is equal to 17.558. Is that enough? Nearest tenth. X is equal to 17.6. Done. All right, we're on part 3. The problems start getting harder. You know what harder means, don't you? More fun. Yes, they do. So, simple quadratic to solve. I'm gonna do the factoring here, and I'm gonna check it using my fancy calculator. So 2 sine squared x plus 5 sine x minus 3 equals 0. I'm going to factor this. 2 sine x, not 5. What the heck am I putting a 5 there for? And just sine x. Sine x. They got to multiply to negative 3 and add up to 5. That should be plus 3 here and minus 1 here. So I should have answers of sine x equals a half and sine x equals negative 3. But I want to check it using my fancy dancy calculator, so I go into menu 3, 3, 1. It's a quadratic. Yep. It's 2, 5, negative 3. Yep, that's my quadratic. Hit enter. Yep, negative 3 and 1/2. Those are my answers. So I got it. I'm good. So 5 and negative. So negative. But I got to remember that's not going to yield me any answers. So I could just do, in my calculator if I wanted to, if my brain is completely shot, inverse sine of a half and realize that's 30, or I can just use my brain. So my angle is 30. Now, if that's positive, that means we're going to be in the first and the second quadrant. Well, the reference angle in the second quadrant, 30 degrees, is 150. So my answers are 30 degrees and 150 degrees. And I cannot tell you how many kids got this. And, you know, it's gorgeous work. It really, truly is gorgeous work. And yet it's only worth a 3 out of 4. And the reason it's worth a 3 out of 4 is because of this right here. The directions clearly said your angle must be between 0 and 2 pi, which means your answers must be in radians, not degrees. So you got to be real careful with that one. So if you don't remember, you take 30 and you multiply by pi over 180 and you get pi over 6. And you take 150 and you multiply it by pi over 180 and you get 5 pi over 6. So these are your answers. Be careful. Gotta love us math teachers. We keep you guessing. Because Sam's backyard gets very little sunlight, the probability that the geranium planted flowers is 0.28. Sam planted 5 geraniums. Determine the probability to the nearest thousandth that at least 4 geraniums will flower. So, a couple things. When we start to tackle this problem, we want to say the probability that it will flower, get your information down, is 0.28. That's 28%. So the probability it will not flower is equal to 0.72. You got to have those directions. Then you got to think about do we want it to flower or not to flower? That at least 4 will flower. So the thing we're looking for is will. So that's going to be our first parenthesis, that thing. And we want 4. So at least 4 would be 4. How many different? 4 or 5. So it's really just 4 or 5. So we got 4 and 5. So what we're going to do is we're going to take 5, choose 4. This is the probability that 4 are going to, and we do our parentheses here. And in the first one goes what we want to happen. Well, we want it to flower. So we're going to put the 0.28 here. That gets the 4. That gets this one. And then what we don't want to happen goes over here, 0.72, and that gets that. And then otherwise it could be 5, choose all 5, 0.28 to the 5th, 0.72 to the 0. So what we need to do is get those decimal equivalents. So, and it says to the nearest thousand, so I should have given myself more room over here, but you have to write out pretty much everything. Let me get out of this. So, menu, probability, combinations. We're doing 5, 4, parentheses, 0.28 raised to the 4th power, 0.72 raised to the 1st power. Now I didn't have to put that raised to the 1st power, I just did it. 0.2212. 0.0221276. And same thing. I don't want to retype all that. Hit enter. I'll change this to a 0. Change this to a 5. Change this to a 5. And hit enter. 0.00172. 0.00172.103. Now I'm not going to rely on the fact that I actually write those incorrectly. I need to add those up because those are both, either one of those can happen. So I'm going to hit enter, plus, and I'll go up to this one, hit enter, enter, 0.02384. So 0.02384. I want to round to the nearest thousandth. So that's 3 decimals. So my answer is 0.024. Final answer. 38. Got 2 left, kids, and then we're almost done. Yay! Oops. If 2 sides of a parallelogram are measured to the included angle is 48. Find the length of the longer diagonal of parallelogram. So since this is a 48 degrees, that's an acute angle. I'll draw an acute angle with one longer. (48), 27, and 32. And it said find the angle, or find the length of the longer diagonal. So notice I put an acute angle in there. So this would be the longer one. So I'll bring the 27 over here. Now, if this angle here is 48, then this angle here must be 180 minus 48. I just all of a sudden pop up and say, oh, it's 132. You'll be like, oh, where'd that come from? 132. Remember, any 2 angles in a parallelogram, any 2 consecutive angles in a parallelogram add up to 180. So the question is, what is this? X. And I'll call this X. And clearly, since we have side, angle, side, we want to use the law of cosines. And now if you don't know it, come over here. Oops, come over to here. There it is, law of cosines, right there for you. Remember, whatever you're looking for goes at the beginning and end when you're talking about law of cosines. If you're looking for an angle or you're looking for a side, they go on the ends, and all the stuff you know goes in the middle. So, I'm looking for x squared. So that means cosine of 132 goes here. The things I know already go on the other stuff. So that would be 32 squared plus 27 squared minus 2 times 32 times 27. Now the beauty of all this is I just have to type this in. So I type in, let's see, 32 squared plus 27 squared minus 2 times 32 times 27 times the cosine of, well, I can't tell you if kids automatically accidentally put sine in there. That's a common mistake. Accidentally putting sine in there, that's a dumb mistake. You don't want to do that one. 20, what? No. And I have kids that'll write that down as an answer. They'll say it's 2. Did I not put the right numbers in? I got a different answer here. What, 32, 27 plus minus 2 times 32 times 27 times the cosine of, oh, why did I put 110 in? 110's not the angle. How dumb is that? So remember when I was talking about kids accidentally put sine in? Well, the other thing kids just put in is the wrong angle. It's 132, right? Wasn't that our angle? Our angle measure is 132, right? And then I'll have kids that'll write down this as the answer, which ain't it. Yeah, 132. I don't know. Why would I get 110? Where did that come from? That's weird. So you get 2, 9, 2. Oh, here we go. I don't know why it was written down there. All right, here we go again. Getting towards the end. 2909.257. Don't skimp. 68779. 68779. Write everything down. But that's not what I'm looking for. I'm looking for the square root of that. And so I'll just do control square root of that thing. By the way, you could just raise it to the half if you want to. Enter. 53.937. So x is equal to 53.937. Do I need any more than that? To the nearest centimeter. So my answer is x equals 54. Catching. Done. I think we're on the last problem, right? Yay! Yay! Page width. No, it's logarithms. I'm going to cry. All right, first step when you're working with logarithms. You don't want to solve an equation with more than one logarithm. So we look here and we say, hey, we're adding. I remember that when I'm adding, what I'm really doing is when I go back and I want to combine them to one log, I'm really going to take those and multiply them. I want you guys to be careful of something. I've seen a couple kids do this. They'll write log x plus 3 of 2x plus 3 times x plus 5 equals 2. But that's not, does this look like it's being a base? You can't write this like this. This is sloppy and this is lazy and you don't want to do it. It's also going to get you confused. It's not, the x plus 3 really has to be drawn way down here at the bottom of that G, x plus 3. My pen's just messing up. And then of what? 2x plus 3 times x plus 5 equals 2. All right, so we combined them. That was step 1. Step 2 is we need to figure out what this exponent will be to give us 2. So what we're going to do is it's all about the base. I don't think I said that right, but that doesn't matter. It's all about the base. So what we're going to do is we're going to write down the base, x plus 3. Now it appears as if that's the exponent. So we're going to swap these. So we're going to get x plus 3 squared equals 2x plus 3 times x plus 5. All right. There's the equation we have to solve. So the first step was to combine them to one log and then realize, oh yeah, I'm going to say, okay, x plus 3 squared is equal to this. And now I've gotten to the equation that I can solve. Well, this is really x plus 3 times x plus 3. Don't give me x squared plus 9. I'll break your legs if I ever catch you and I don't even know who you are. So this is going to be x squared plus 6x plus 9 if I double distribute the left side. And if I double distribute the right side, or FOIL, or whatever your teacher calls it, 2x squared, this gives me 10x and 3x, so that's plus 13x, plus 15. Now, I want to have my x squared positive, so I'm going to take all these things and move them over. So I'm going to subtract that x squared, bring it over. I'm going to subtract this 6x, bring it over. And I'm going to subtract that 9 and bring it over. So I get, I don't know why I put a parenthesis there, x squared plus 7x plus 6. Ooh, they were nice to us. So, wow, the factoring here is a joke. X plus 1, x plus 6. So my two answers are x equals negative 1 and x equals negative 6. Now, all morons, I like to call you morons, it's a term of endearment, just say, oh yeah, I'm done with the test, oh my god, I can take a nap. What? I didn't get that right? What? What do you mean I didn't get that right? Huh? What the heck's wrong with you? Of course I got it right. Check your answers. Check your answers, especially these 6-point questions. We like to mess with you. Check your answers. Type all of this in. So first thing we're going to do is come over to our calculator. We're going to say, clear out all the crap so we make a nice fresh graph. And we're going to say, oh, one of my answers was negative 1, so I'll stake negative 1 and I'll stow it into x. Now, you have to, this is obnoxious. You got to do this once, log. And then it was what? X plus 3. And this was 2x plus 3. 2x plus 3. Plus log. Yes, this is a pain. But would you rather get a better grade even though it's a pain? I think you would. If you don't, you're in the wrong place. The world doesn't need any more lazy losers. X plus 5. Take a look at it. Make sure you put it in there right. Did I put it in there right? 2x plus 3. Got the base right. X plus 3s. I got x plus 5. Hit enter. 2. I told you. I told you it was right. I told you it was right. but you have to check the other one. So we'll take negative 6 and stow it into x. Now the beauty is, I've already typed this whole line in. I just have to hit enter. So now it's retyped it, but now it's going to use negative 6 as our x value. And non-real calculations, I have an error mode? Oh my god. What? That's because negative 6 is not a solution to this. And the problem with it is if you type in negative 6 here, won't that give me a negative base? And your base has to be larger than 0. It can't be 0. It has to be larger than 0. So negative 6 is not a solution. So you come back over here. Come back over here. I don't know where my mouse is. Minimize that. Come back over here and you say, okay, all right, Mr. Krause is right. He's always right. Negative 6 is not an answer. My answer is negative 1 and only negative 1. Ka-chang! And you are right. I hope you did well on this test. I really, really do. If you are enjoying my videos, or at least they're helping you, you may not be enjoying them because it's mathematics, and sometimes that's quite painful for some of you. But if you are getting some use out of them, hit the subscribe button down below. If you get 100, email me. I want to know about it. I'll put you on my wall of fame on MrKrauseMath.com, which I don't have a wall of fame yet because I have yet to get a kid get 100 in 20 years. 99s. Lots of 99s. It takes a freaky mind and someone working very hard to get 100. Good luck, kids. Summer's right around the corner. Keep working hard. Do not quit. You don't want to be the kid working at McDonald's, living with 4 of your friends, driving the same car that's all a piece of crap that has to go in the shop all the time because you can only rent one. You can only get one car and you have to get on your bicycle and then you got to go to school and then you have no boyfriends and you have no life. You don't want that. Work hard. Or girlfriends. Bye, guys.